Well, hey physics folks, welcome to Doc Onco's Physics. Keith Onco here. What we're going to be doing today is taking a look at one of several of Newton's laws problems that we're going to be solving. We're going to start out with some simple problems and then get into some more complex problems. But today what we want to look at is we want to look at two blocks that are being pushed along a horizontal frictionless surface by a force of 20 newtons to the right as shown. What's the force exerted on the 3 kilogram block by the 2 kilogram block? So here we have our two blocks. All right, we'll call that one block 1. We'll call that one block 2. This writing is a little bit thick here. I guess it's okay. All right, so we have these two blocks, we have one force, and we want to know what the force exerted on the 3 kilogram block is by the 2 kilogram block. So first, let's take a look at the different forces that we have on each one of the blocks. Let's look at the 3 kilogram block first, okay? Because anytime we have a Newton's laws problem, what we want to look at, what we want to do is identify all of the objects in the problem, right? And then draw free body diagrams or identify all the forces that are on each one of those objects. So for the 3 kilogram block, we have the 20 Newton force that is acting to the right. Okay. We're also going to have a force on the 3 kilogram block due to the 2 kilogram block that's going to be pushing to the left. Okay. We have our force due to gravity on the 3 kilogram block, and we also have the thing called the normal force. Whoops, it should just be an N on our 3 kilogram block. Okay, so those are the forces on the 3 kilogram block. Let's look at the 2 kilogram block. Well, on the 2 kilogram block, the 20 Newton force, all right, this 20 Newton force here does not act on the 2 kilogram block. It only acts on the 3 kilogram block, so we can't include that. Okay. However, we do have the force from the 3 kilogram block that acts on the 2 kilogram block. Okay, and we're going to label these things. We're going to label this one the force on 3 due to 2. And we're going to label this one the force on 2 due to 3. Okay, and that's usually the conventions that I use. All right, so we've identified all the different forces. I did not identify the forces in the y direction for the 2 kilogram block. We're still going to have the normal force on that, and we're also going to have, let's see, the force due to gravity on that. But we're interested in things going on in the x direction. So our y direction forces are not going to be interesting to us in this problem. All right, we want to know the force exerted on the 3 kilogram block by the 2 kilogram block. All right, so first thing we're going to do after we have drawn our free body diagrams and we've identified the forces on each block, what we're next going to do is we're going to write equations for each one of the objects. So I've labeled the 3 kilogram block object 1, the 2 kilogram block is object 2. So the forces on block 1 are going to be, all right, the sum of the forces are going to be what? We have 20 newtons to the right, and anything to the right we take as being positive, so it's positive 20. All right. What's the other force on the 3 kilogram block? Well, it's F32. It's the force on the 3 kilogram block due to the 2 kilogram block, and that's going to the left, so that's going to be a negative force. All right. So it's going to be minus F32, all right? And those are all the forces in the x direction. I should put a little x down here, okay? And they're going to equal ma, because here we have our equation, right? The sum of the forces is equal to ma. And it's critical that we recognize it's the sum of the forces. It's not just a force, or it's not just F equals ma, it's the sum of the forces equals ma. If you get to use this equation the proper way, this equation will be your friend for a long time, at least as you get through mechanics. All right, so ma, well, the mass of our 3 kilogram block is 3 kilograms, right? And we don't know A. Okay, we'd like to know A at some point. It's going to help us out. So that's the equation for block 1. Now let's look at the equation for block 2. All right, what do we got? Well, for block 2, we have the sum of the forces, again, in the x direction, is going to equal F23. All right, that's the force on block 2 due to block 3, and that's going to the right. And are there any other forces in the x direction on block 2? And the answer is no. Okay, so F23 is going to equal ma. Well, m in this case is 2 kilograms. And because our system is a system of 2 blocks, they both have to accelerate at the same rate. Okay, so the acceleration for the 3 kilogram block is going to be the same as the acceleration for the 2 kilogram block. We're assuming they're rigid blocks, and as soon as 3 moves, 2 is also going to move. Okay. All right, so we've got 2 equations. We've got what appears to be 3 unknowns. However, what we have to recognize is that F32 and F23 are related by Newton's third law, right? For every action, there is an equal and opposite reaction. So what can we say about the magnitudes of F32 and F23? Well, the magnitudes are the same, okay? The directions are opposite, and we've already accounted for the directions, right? The direction there, all right? And the direction here is positive, all right? So we've already accounted for the directions, but the magnitudes are the same. So what I can do is I can substitute F23 in for F32, all right? Or I can substitute in a value that we got for F23. All right, so let's do that. Let's take this value, 2 kilograms times A, and plug that in right there, because we said they're equal and opposite. Okay, so what we get is we get 20 newtons is equal to, 20 newtons minus, not equal to, 20 newtons minus 2 kilograms times A is equal to 3 kilograms times A. All right, what we can do now is we can move the 2 kilograms times A over to the other side, move that over to there, all right, and we get 20 newtons is equal to 5 kilograms times A, and A turns out to be 4 meters per second squared. So we've just come up with our acceleration, which is a nice thing to have. So we have our acceleration now. All right, but we're not looking for the acceleration. We're looking for the force that's exerted on the 3 kilogram block by the 2 kilogram block. We're looking for the force on 3 due to 2. We're looking for that guy right there. Well, we now have A, right? We know what A is, all right? So we can just plug that back into the equation. So I'm going to go over to the left-hand side of the screen here. Say that 20 newtons, all right, minus F32, okay, is equal to 3 kilograms times A. Well, A is now 4 meters per second squared, or 20 newtons minus F32 is equal to 12 newtons. Okay, and what does F32 turn out to be? It's going to be 8 newtons. Okay, so the force on block 3 due to block 2 is going to be 8 newtons, and it's going to be to the left as we have drawn the direction over there. All right, so what's the key here? The key is in identifying each object, right? We have 2 objects, we have 2 blocks, drawing the forces in on each block, okay? Then writing our equations, substituting the forces in, right? We don't, and again, we're not always going to have values, right? We had values in some of them, we didn't have values in others. Just follow the process, all right? Write an equation for each one of the blocks, and then you're going to find that you can do substitution, okay? Substitute in the right values, solve for what you're looking for, and you should come up with the answer. I hope that helps, and have a great day.